Boom. Boom. Okay, so I'm Ferris. Hello. This is the Salt Lake City Python meetup group. If you're looking for the Ember meetup group that is not here, that you're the wrong meetup group. PHP meetup group, you're in the right place. Okay, so this is Salt Lake City Python. It was started when Joe Reese and Ken Myers, another coworker of mine, we randomly ran into each other at Sugar House Coffee, and they had a Django admin page open, and I said, hey, we should get a Python meetup group here. They were like, but there isn't one. And I said, yeah, it is. It's just you have to drive south on I-15 during rush hour, which is just great. It's just a lot of fun to do. So we decided to start one in Sugar House. And first it was the web development meetup, but it turns out that I found out. So that's pretty cool. So we're just the Salt Lake City Python meetup. The umbrella organization is Utah Python. That is the one that sends raffle prizes and other funding and helps distribute funding to other meetup groups around the state. Primarily we send things to Python at the Point and to Python Utah North. Python Utah North represent right there. Oh, hi. I thought I recognized you. We got two members from South. I'm sorry.
Anyway, the next Utah North meeting is a postponement of last month because we didn't have enough members show up. But it's ham radio with Python next week.
Ham radio with Python, that's pretty cool.
Yeah, on Wednesday.
We also have I mentioned Python at the Point. Provo is now part of the Python at the Point. Who's part of the Python at the Point meetup? Anybody? Can you represent? Sweet. And which building is that?
It's the Canopy office.
Canopy in Lehigh. So, and when's the next meetup? I think it's next week. Next Thursday. Sweet. There's also Girl Develop It, Salt Lake City. Anybody part of Girl Develop It? Represent? You got to do that when you're part of Girl Develop It. Do you know when their next lunch thing is?
I think it's
Tuesday.
Don't quote me.
No worries. It is Tuesday, so no, I'm just kidding. Yeah, so Girl Develop is a pretty awesome organization. They do workshops, so if you ever want to teach a workshop, you can always do that. I taught a Django workshop with them. Lots of fun. Let's see, what else do we got? There's so many meetups. PyLadies. Anybody part of PyLadies? Oh, hi, Isla. Isla gave an awesome talk at the last, 2
times ago.
at Open West and and our meetup, but yes, and at Open West, and it was awesome. Sweet. Do you know when the next PyLadies meetup is?
I believe it's end of the month.
End of the month. Okay. So I'm glad we didn't butt heads again by moving things 1 week after. Sweet. The other new meetup that we announced last week is the data engineering meetup. So Joe Reese, he's like, Ferris, you're cool, but I want more data in my life. So he decided to do a data engineering meetup, which I believe is the third Wednesday every month at 6:30 at wherever you click there. It is a consistent location, and it's completely leaving my head right now. Does anybody know offhand? I think it's at Overstock. No?
This next time it's at Pluralsight last.
Pluralsight, that was it,
It
yes.
was Overstock last. The first
Okay.
time.
But it's in that little corner at Cottonwood, right? Isn't that where both of those places are? Is Pluralsight up there?
It's the Lucid building.
Oh, right, okay. Which one am I? Instructure, that's what I'm thinking of. Okay. Sweet. But yes, there's a data engineering meetup, which is not to be confused with the data science meetup. They're more about getting that pipeline and things set up so that you can, gather the data in the first place and then do the fun data science. Sweet. We got a couple websites. They're right there. We got a couple repos. They're right there. Sponsors are Pythonistas like you. Thank you. If you donated, thank you. If you didn't, that's okay. We'll see you at the next time. Maybe you didn't find the pizza to be good enough. I'm sorry about that. I'm just kidding. I don't care. I love your donations, but we also have other sponsors like X-Mission. The University of Utah has given us the venue, and Tech Systems has consistently provided support for both, not just the raffle prizes, but I know that they've placed a couple of our members in jobs that they would not have had otherwise. So they're great. Anybody from Tech Systems here tonight? I don't think so.
Hey, just a question. You know, on the one, there's the data engineering one.
Yes.
There's also on that same night, there's a PyData.
Ah, is that one at Recursion Pharmaceutical?
No, it's at, I don't remember where it's at.
Yeah,
Larry
it's-
H. Moore.
it's,
Yeah, it's Larry H. Moore.
yeah, Larry H. Moore.
Huh, there's a lot of Python groups. Recursion Pharmaceutical Recruitment Night, so yeah. That's all I'll say about that. Sweet. New sponsors, always appreciated. I had a couple people actually message me this month about that. Sorry for not getting back to you guys sooner, but I was on a little vacation, so yeah, that should be fun. All of our past expenses and sponsorship are located at Salt Lake City Python/money. So we have open accounting. The only thing you can't see is specific individuals, but you can see generic sponsors. So for example, it'll say Pythonistas like you as a sponsor for that month, or it'll say Tech Systems or X Mission. So yeah. Oh yeah, I didn't give the X Mission spiel. Should I give the X Mission spiel? X Mission, for when you don't want deep packet inspection on your packets. X Mission, because net neutrality should be a thing. Okay, X Mission's your locally, organically grown, high-speed internet shop based in downtown Salt Lake City. If you have Utopia, you're probably using X Mission for your ISP. They're awesome. I feel like the fans just turned on, did they? No? I don't know. Sorry.
That's a new projector.
Oh, sweet.
I just noticed that. That's what I was pointing at.
Sweet. What else? I lost my train of thought. It's kind of hot in here. Sorry about that. We try to figure that out. I don't know. It's Utah in July. So last time we had what was it? Two Julys ago, past 2 Julys from a long time ago, we had a power out at the very end of the meetup. That was pretty funny. Anybody remember that? Anybody was there for that?
Is that Zaniac?
Yeah, that was at Zaniac. That was a pretty funny one because the intro was your favorite thing to do during a power out. So that's how we did Dylan was there, you remember that. The power out of, 2014 and 2013. So yeah, good times. Sweet, speaking of new members, we always do a thing where you introduce yourself, what you're doing, and something non-code related. So this time it's going to be favorite ways to escape the heat. Now, caveat here, if your favorite way to escape the heat is to go to like an internet cafe or just sit in front of an AC while coding, I want another one, okay? So I'm Ferris. I am the senior backend janitor at Teem. My favorite way to escape the heat is probably either a slip and slide or try to make my way to a beach of some kind, if not a wave pool. Sweet. Who else is new? Raise your hand. I know there's more. Come on. Paul, you go for it.
Hi, I'm Paul. I work in a biology lab on campus. I'm kind of doing some data analysis right now, so I started working with Python like 3 weeks ago, so I don't know anything. Actually, I'm learning a lot. It's awesome. Favorite way to escape the heat? I really like to go swimming, so anytime there's an opportunity to just go swimming, I'll do it. Thank you.
Sweet. Paul, I invited him actually on Monday. We go to the same primary children's hospital shift, so that's a lot of fun.
It was pretty awesome. I just mentioned I'm doing Python. He's
yeah.
like, oh, you should come to this thing. I'm like, all right, cool.
Yeah, I'm kind of into Python. I don't know if you know this. But yeah, so actually Paul's project is pretty neat, so I would definitely try to catch him at the end of this if you're looking for, if you know a lot of Python and you want to put those skills to use. That's definitely sounds like a really interesting project that they're working on in that lab. Who else is new? We'll start with this gentleman over here.
Yes, my name is Mike. I am a data scientist at a marketing company called ClearLink. And favorite way to escape the heat? Cold shower?
That's fair. That's fair. There's so few ways. I was watching Canadian TV because I was in Canada, and they had this thing where these kids put a watering can in a basketball hoop, and then they put a hose in it, And it was on the news as like, this is the greatest invention ever. This is such a great way to escape the heat because they're having like, it's like 100 degrees over there and they don't know what to do because it's Canada and that doesn't happen usually. So anyway, who else?
Posers.
You're Canadian.
I get to get away with it.
All right, this gentleman in the burgundy shirt.
Name's Josh Clay. Currently looking for new employment right now. Favorite way to escape the heat? Probably just a shaded hike later in the day when it's not heat or when it's not hot.
Escaping to the mountains.
Yeah.
Always a solid choice in Utah. Anybody else? This gentleman in the very back.
Hey, I'm Brett Milash. I'm a staff scientist upstairs here at the CHPC. Favorite way to beat the heat? I've been paddleboarding up the East Canyon Reservoir lately. Super cool, nice altitude. Can't get it.
And then do you purposely fall off but pretend you did? Yeah, there you go. That's the best way. You pick the next person. Who else is new?
So,
Oh,
good evening
okay.
everyone. My name is Karthik. I have graduated with Masters in Mechanical Engineering, Robotics Economics track. Now I'm actively looking for jobs. Best way to beat the heat, I'll sit under an air-conditioned room.
Sit in an air-conditioned room. That sounds very straightforward. I like it. Who else is new? This gentleman in the very corner.
Back here, cool. So I'm Oliver. I'm a software engineering intern at Newbold Healthcare. Best way to beat the heat? I like to eat ice. It's kind of cold.
Nice. Ironically, drinking hot tea also works for some reason. I don't know why. This gentleman in the baseball cap.
Hello, I'm Isaiah. I'm a software engineer intern, and I don't escape the heat. I join it because if you can't beat it, join it.
Fair. This gentleman right here.
My name is Paul. I'm a student here at the UCS, and I'm not working right now, but I'm looking for something for the fall to work with my classes. And I like to beat the heat with popsicles.
Popsicles.
Coconut popsicles.
Very nice. Oh, and I met you.
I'm Wesley. I'm a student at Newmont, which is downtown. I'm graduating soon in like 1 month-ish. And to escape the heat, I usually wear a jacket, so I'll just take it off.
Very nice. That works. Anybody else who's new? There we go.
So I'm Melinda. It's nice to see some familiar faces. I'm a PhD student here in mechanical engineering. See some of my students here too. And due to the heat, I'm a big movie fan, so I'm hoping to see Jaws in the Water. If you guys haven't seen that on Facebook yet. Jaws in the Water. Yeah.
Linden Marina, right?
I think so, yeah.
Wait, where is it held?
It's at the Linden Marina.
The Linden Marina?
Yeah, I remember it's in Orem.
Ah, okay.
Yeah.
I was like, there's water in Utah somewhere?
Yeah.
That's new. All right. Anybody else new? Going once, going twice. Is that a chance? Sorry about talking about heat when it's kind of hot in here. That's my bad. But
take a trip out to Morgan and float down the river.
Yeah, that's a good one too.
Yeah.
Just make sure you know how to swim.
Right.
Who is hiring? Team is hiring. There's the link. Who else is hiring? Anybody else know of anybody else in the valley that's hiring?
Maybe next month.
My
All
company's
state?
hiring, but
No,
not Python developers.
Through the
Are they hiring computer science people?
Java developers.
Never mind. That's okay.
We're also hiring machine learning analysts and machine learning scientists.
Overstock?
Overstock.
Yeah.
What's that? Python based. Well, you know, just
Where's Google use?
not all Java.
No, just if you're a developer. I'm just talking about the non-PhDs.
What was the company?
I don't know, it's cool. Oh, overstock.com.
Oh, okay, same place.
We're hiring Java developers. My team specifically is looking at testers and
Sweet. Anybody else? Who put Viva?
I did.
Oh. Sweet. Anybody else know of any tech jobs coming up around the valley? It's a weird time because Q3 just started. So companies are like, oh, we have the budget for this or we don't. So we'll see. Probably Q4 it'll start picking up again. But we'll see. Q1 is usually the best time to get hired, by the way. For any astute students who are looking for jobs, that's definitely your best bet to start looking in November, and you'll probably get hired in January. So.
Yeah, the place I used to work called Front Analytics is hiring data analysts.
Front Analytics?
Front Analytics, yeah. Using Python R.
Python R. Awesome. Okay, who's looking? Dad? Oh wait, no, he finally got hired, so we're good. Yay! That's the thing. And guess what language he's coding in? Java. COBOL. He actually got a Python job because of this. So.
What?
Yeah, right?
Where at?
Where are you? We're at for this Viva Consultants.
Cool.
Yeah.
Working at Allstate.
That's Allstate stand. Anyway, who's looking? Anybody who's willing to stand up and market yourself?
Sure.
Your name, and then if you have access to this, put in your details, okay?
Okay, I don't have access, but maybe later.
Yeah.
So my full name is Karthik Suresh. I'm looking for jobs in the areas of data scientist, data analyst, and machine learning engineer positions. So yeah, and you can connect with me on LinkedIn. Karthik Suresh is my full name.
How do you spell your full name?
K-A-R.
Okay, okay, you got it. Sweet.
Thank you.
Who else is looking? Stand up, market yourself.
So my name's Josh. I've got a background in high-frequency trading and experience in Python and C++. Looking for data science, machine learning, and also development jobs, kind of open. So.
Can I just write down quant?
Sure.
Sweet. Anybody else? Now's your chance. Stand up, market yourself. No? Going once? Going twice? All right, community news. What's going on around the general Python community, the local Python community? Oh, I forgot to write down something. Probably every dev at Domo. Okay, let's keep going. Too soon? Pardon my Schadenfreude. I think we're all feeling it though. Community news, DEF CON 2018. Anybody going to DEF CON? Anybody ever make that trek down? It's on my bucket list. I really want to go. Anybody know how you pay for a ticket to DEF CON?
Cash.
Cash at the door. I know, pretty interesting. I'm thinking maybe, probably not this year, but maybe next year we should like get a bus together.
I'd be down for that.
Yeah, that would be fun. Has anybody seen some DEF CON talks that like struck you? Yeah? Which one did you like?
Oh my god, the author of, because I'm into developing Scrapey, the author who wrote Web Scraping.
Web Scraping, the guy.
Python.
Nice.
Awesome talk and pretty much.
One of my favorite ones was about a guy who figured out how to pretty much get any satellite signal, because it turns out they're not encrypted. Really? So he was getting satellite feeds that you wouldn't even think about, like when a reporter sets up at a news whatever, they just have the van up and then they just open a feed and it's just open. So he sees stuff like the reporters like scratching their head or picking their nose while they're waiting for them to be actually on. So that was pretty interesting. There was another one that was about the RFID chips that you might see that you use to like unlock a door. And what I really liked about that one wasn't the talk itself, but they actually stopped in the middle and they said, "I spotted the Fed." And you guys know that game? So like, yeah, federal agents are always at DEF CON, and if you spot them, you get to point them out, and they get, you know, their faces are plastered on every single slide from then on out. DEF CON it's a conference that is unlike any other, probably. I would consider it to be the Burning Man of our industry.
That is a good analogy.
So if anybody wants to join me for Nerd Burning Man next year, I'm totally down. Any other community news? Oh, by the way, DEF CON starts August, I think, 1st this year. I'm not sure.
People do even take their own little, like,
yeah,
displays and share them with each other. Like,
yeah, no, they do. They take their own hacks and they bring them, just like Burning Man. You pack in what you're willing to lose electronically, just like Burning Man.
People bring fresh computers.
They do. Wipe one down. Any other community news?
I saw a post that I want to say it was on. Sorry, it basically, the highlight of it was Python finally overtook Java. Not Java, but JavaScript as the number one language on most forums for requested.
So that mean it has more problems?
I saw it on the RSS feed.
DigitalOcean released a study of popular microservices languages, and Python just barely eked out over Go. And that's a new trend. Go was beating Python, and then people are like, oh wait, I can do this in Python, and then it's pretty much written for me. I just do import my microservice stuff. So, which I'm kind of doing at work right now. I'm using something called Thumbbar for our thumbnailing, and it felt like import Thumbbar. Okay, my work here's done. That was a 2-week sprint.
Released between now and our last talk.
Say again?
Wasn't 3.7 released between now and our last talk?
Officially released, yeah. I know because when I did brew upgrade, it broke everything. So sweet, happy Python birthday. 3.7 introduces a couple cool things. The main one is data classes, yeah. So I really want to do like a quick shindig about data classes, but they're pretty much like named tuples on steroids. They're amazing. You can do stuff like, hey, I want my data class to be sortable. So you just add like, okay, what do you sort it by? Okay, we're done. Really easy to use. Anybody use 3.7 yet? Data classes yet?
The best thing is all like your init and like repr.
Yeah.
Is all done. That's just the nicest thing.
It really is. It really is. So like all that object-oriented programming that every other language has gotten to play with, we finally have it now. It's pretty fun. Well, we have it in a much easier to use way. Yeah. Sweet. Anything else? Anybody mess with, who's still on 2.7, by the way? I'm raising my hand too. I'm so sad about it. 2.7, you got, what is it, a year and a half? Maybe less left? Tier? Yeah, that's pretty fun. Sweet, new topics, new speakers. We need an August speaker, I believe. I don't think we have one. Anybody willing to give a talk? I know that somebody grabbed me. If you don't want to talk right now and tell me about your talk, you can grab me later. But I feel like if you don't feel like speaking up now, then maybe you shouldn't be a speaker. I don't know. Get it? That was subtle. Too subtle. I'd like to do a talk on Django channels, but lately I just have not had time to put together a proper talk. We've had a lot of suggestions here, it looks like. You can see those okay? Bob wants to do one. I don't know. Oh, look. I get to edit this one. That's how long our thing is. Bloop. Okay. Cloud stuff. Stuff. PySpark. Somebody wrote productionizing Python. There it is. Productionizing this. This one is actually going to be the talk next week at the data engineering meetup. So if you're interested in that, definitely go.
Is it?
I believe so. No?
I'm giving that talk. So.
Oh. Is it not next week?
No, that's, I don't know where the title came from, but yeah, it's roughly that.
Okay.
We're talking about how to package up Python and productionize it in an enterprise setting.
That's not your email, is it?
No.
Then you have competition. Sweet. Making your data science code reusable. Let's see. Bloop, bloop, bloop. Don't need all this. Okay. So we'll take a quick break to cool off between now and the next talk, and that lets us set up and grab water. Now's your chance to use the restroom, grab another slice of pizza. Please keep in mind, kind of a new thing, we're not here at exactly 7:35. We're like right on time right now. Very happy.
No PDBs needed. Just breakpoint.
Well, it's the best shirt. It has them so many pockets, so I can just be like...
It's a cargo shirt.
I know, it's a cargo shirt. I feel like a dad. Go.
Oh, yeah.
Okay. Wherever you want to...
I'm dbscan, he's k-means. So thanks for coming. My name is Sean Siemens, work at Overstock. Today's talk is kind of an offshoot of a little learning project I did earlier in the year. I was tinkering around with like XGBoost and a couple other algorithms and realized I really don't know scikit that well, which is kind of bad for a data scientist, I guess. Should at least be competent in scikit. So I decided to use the Titanic data set from Kaggle to kind of learn scikit. So I'm going to take you through my notebook that I actually used to compete in the so-called competition. First, I'll go through an overview of scikit using the Titanic data set. For those that don't know, of course, there's a site called Kaggle where you can compete in machine learning type competitions. The competitions are of a nature where you get your training data, your test data, train on your training data, you submit predictions on the test data, you get a score. Highest scores win a lot of money sometimes, tens of thousands sometimes. Titanic is not one of those. It's more of a learning, kind of a learning data set. It's still a competition in the sense that you can, check your score on the leaderboard. But there's no prize money. It's actually been going on for years. It's just sort of there to sort of experiment and get to know scikit or whatever your machine learning tool of choice is. Typical Kaggle competition looks like this. Overview of the problem. The Titanic data set is a binary classification problem. And what you're trying to classify or predict is whether an individual passenger survived the Titanic or not. Kind of fun. Got your data. As I said, you've got your training set. Training set has labels. Labels are the things you're trying to predict. A test set has no labels, so you make your predictions, submit to the leaderboard. You can submit, on this one you can submit something like 10 times an hour, something like that. I think I submitted about 40 times before getting my high score. Got an 81.8, which puts me somewhere in the top 400 to 500 out of 10,000, so 4 to 5%. So yeah, this is just kind of a fun one to play around with. Kaggle competitions also have something called Kernels. Kernels are sort of a combination blog and notebook where people write up their, their approach to whatever the competition is. It's a great learning resource. Of course, discussion, self-explanatory. That's about it on the Kaggle stuff. Any questions so far? Cool. So we'll just jump right in. It's going to be a lot of pandas, of course. Any data-related work is going to involve pandas a lot. I'm just going to do a high-level overview of scikit itself. If you have any questions, just jump right in. So we load our test and training data sets using, again, pandas. Taking a peek at the data, this is what we have to work with. We have a passenger ID, which is just unique identifier, not really useful until you submit your predictions. This is your label, the thing you're trying to predict, whether the individual survived or not, what class they're in, their name, sex, gender, age. This variable is how many siblings or spouses they were traveling with. This is how many parents or children they were traveling with. Every row is a real passenger. Their ticket code, how much they paid, what cabin they were in, and where they left from.
How many parents or children they're traveling with? So
if
you're a child, if I have my parent there, my parent has a 1 and I have a 1?
Should be. Theoretically, I guess you could have both. You could have your parents and your children. So it should be a sum of both if you were.
Oh, if you were
did have both.
Somewhere in there. Yeah.
And same with siblings and spouse,
Okay.
So we've got kind of a mix of, more continuous features, more categorical features, some not so sure, some more obvious features, some not so obvious features, and that's kind of what makes it kind of a fun data set to play around with.
What are the empty cabin values?
Don't really know what those are. I don't know if they weren't assigned one or if it just wasn't recorded, honestly. It's a good question. I guess I should have looked at that. But, so yeah, some are obviously useful. Some maybe you have to tinker with and sort of featureize them, turn them into something useful. Any other questions so far? So I'm going to run through kind of a typical process, covering the high-level packages from scikit. First thing you're typically going to do is some sort of pre-processing. We're going to get the data in shape for classification using the pre-processing package. First thing we're going to do is take a look at missing values. As you can see up here, we've got lots of missing values. Cabin has quite a few, H has a couple. So we're going to fill those in. From the pre-processing package, we've got an imputer class, which lets us impute based on different strategies. So for the numerics, we're just going to go with a median, just kind of simple, straightforward approach. And so we're going to fill in the fair and age, which are our numerics, with the median.
What's imputer mean?
Imputer is a fancy word for thing that fills in the blanks, I guess. There's also a categorical imputer. I chose to use this categorical imputer from the scikit-learn pandas module, which is a whole other module that kind of bridges the gap between pandas and scikit. So I guess it's worth noting that the scikit categorical imputer wants you to go ahead and convert all of your, say, categoricals to a number. So this allows you to skip that step. So I use that on Embarked. Cabin, I decided to just fill it with an unknown constant, like a constant that actually represents unknown. So after doing all that, we're left with no missing values. So we're on our way. Next comes encoding. Encoding for categoricals in particular, we're going to use one-hot encoding. One-hot encoding means you take your categorical values and sort of explode them out into separate columns per value. So Embarked has 3 possible values. One-hot encoder will turn that into 3 columns, one for S, one for C, one for Q. So I'm going to do that on the class variable, the Embarked, and sex. And so this is what we end up with. As you can see, there are, for each of these categoricals, we're missing one value. It's because I used the drop first option. When you have in features or in categorical features, you can always derive the nth one if you know the true false value of all the others. Does that make sense? So if I know they're not male, I know they're female. If I know they're female, I know they're not male. Simple. And finally, I'm going to split the training and the test set. I guess I should have mentioned, I've been doing this with all of the test set and the train set sort of concatenated. So all of the data at once. And I'm going to split them back up for classification later on. Another useful item is scaling. I'm not going to use it, not really going to use it here, but going to cover it. Simplest way to scale is to, from the pre-processing again, simply import a scale function. You can apply that to as many columns in your data frame as you want. Scale, I guess, normalizes in the sense that it reduces your values to the number of standard deviations from the mean. It's really important for distance-based type algorithms, k-means, k-n-n.
So we're scaling the age in that case?
Yeah, and that was just for display, but I'm not really using it. But
did you also scale the prices?
I did not.
Okay.
No.
Would that be something you could potentially scale?
Oh, sure. Any numerics. Yeah. So that's for a quick one-off. A better way to do that is to use the standard scaler, also from pre-processing. This gives you a reusable object. So you fit, and you'll see this paradigm a lot. You'll see fit and transform, or fit and predict. So we're going to fit the standard scaler on the training data, and then we're going to transform the test data using that scaler. And so the cool thing about this is it gives you, sort of a reusable model or object transformer, I guess I should say, that you can use on other data sets. That's kind of a standard, kind of a best practice too, that maybe you don't hear about much, is that you should sort of, for scaling in particular, you should sort of fit on your training data and then transform on your test data separately. In other words, you wouldn't concatenate them together and do your scaling. Make sense?
So is this output in standard deviations away from?
This is standard deviations from the mean.
From the mean.
And another way of saying that is you don't want to, you want to keep your test and training data apart.
Yeah.
So you wouldn't use the mean of your
And this,
of the whole sets for both.
Exactly.
You
exactly.
treat the test set as totally separate from your training set.
Yeah. And this FAQ kind of goes through that as to why. That's basically what Dylan's saying. The idea is keeping the two data sets sort of pure.
Not specifically about this, but like when you're using that standard, when you're standardizing like that, what if you have like some outlier that's way out there? How do you like take the log of it, or is there a better way to handle stuff like that, or just drop it?
So I guess you can do it multiple ways, and I'll talk about one other way you can scale in just a second that might address that. But yeah, I guess it's worth noting, theoretically your range is sort of infinite. Realistically, it's probably going to be something like -4 to 4, -3 to 3. But yeah, if you have extreme outliers, you can. I mean, sometimes you can just simply chop off those outliers, right? Anything more than 4 standard deviations, you may just want to not use it.
Or if you have like a really non-Gaussian distribution, something with like a big tail, you wouldn't want to use that sort of scaling for that.
Right. Good point.
Some other scaling.
This is probably best for normal-ish data.
One simple, easy thing to do in that case is if you have a big logarithmic tail, just take the log of your data, and then
which may turn it to a normal shape.
Right. You get better predictive power out of that, and you don't get confused by all the outliers.
I did an initial course in data science, and one of the things they mentioned was to visualize things first. Are you at a point where you don't really need to anymore, or were you going to get into?
Oh no, I do. So
I don't know if you just like
I'm not,
dog. Like you just stare into the matrix. And
blonde.
I'll actually show a couple visualizations on the submission notebook where I do that. Develop a feel for the data. So Scalar also gives you an inverse method where you can, go back to your original data, kind of handy. So another approach that may address your question is that there are other scalars. Min-max scalar is a common one, of course. The default would be it will scale to the 0-1 range, and so that's the min-max scalar. Basically, scrunches your data to whatever range you want. Default is 0-1, but you can do -1 to 1, which is a common one in data science, machine learning. There's I guess a slightly more robust one. I don't know the details of what makes it robust, but that handles outliers in particular better. Because even a 0-1 scalar, it may scale to a range you want, but if you got some extreme outlier, it can really skew your data.
Probably like a quantifier base.
I'm guessing it just spreads them better somehow. So that's pre-processing. Any other questions on that? Cool. So point of pre-processing is generally, getting your data in shape for things like classification. You can, once you've done all this work, it can be very simple to just throw any algorithm you want by importing, fitting, and predicting, and you've got some predictions. Pretty simple. They may not be very good predictions, but you've got them. So yeah, it's actually doing predictions can be very simple if you're just sort of using, canned algorithms. You can do the same thing with a bit of tuning, so you can specify the parameters you want. These parameters are what, kind of affect the behavior of the different algorithms. You can get your predictions as, ones and zeros or whatever fits your situation. You can also do probabilities. So you can kind of see, the nice thing about probabilities is you can maybe actually round up or down based on some threshold. So you can be, a little more conservative, a little more liberal on your positive classifications, depending on your situation. Got lots of different types of classifiers. We've got tree-based. Again, it's as simple as importing, fitting, predicting. We've got some ensembles. There's a whole module of ensembles, and it's little things like this that really kind of amaze me. I mean, I expected a lot, but yeah, there's just a huge number of classifiers and then variations on classifiers. It's pretty crazy. So, ensembles are basically when you take multiple classifiers and try to combine their results into one final classification. One of the oldest is a boosting type algorithm called AdaBoost, probably maybe the oldest. One of the most common, of course, is random forest, which is a Bagman type algorithm, tree-based, of course. And then finally, the XGBoost, probably everyone has heard of that. It's kind of famous for winning a lot of competitions these days. Non-deep learning approaches, I guess, seems to be one of the best. And it's just another, more complex tree-based approach.
Yeah, that's a separate library.
Yeah, it's worth noting that is a separate library, but you can use it like any other algorithm. So I can plug it into scikit's cross-validation libraries or grid search libraries, etc.
Is there supposed to be something among these three that helps us to see which one is better than the others?
That's where...
Sure. We'll kind of get to that in a bit. They don't inherently come with something, if that's what you mean, but they're... Yeah.
So what you're showing right here is just the capability or ease, but it's not necessarily showing
Exactly.
at this point.
Exactly. Just how to do predictions. Like I said, not necessarily good predictions yet, just doing predictions.
And you have your test X, right? And so that's where test X and test Y, so the train X, train Y, into the predict you put, test X. So there is a test Y, and if you just compare that based on what you predicted, then you can see how close you got.
Right. In our case, in the case of this data set, we do not have the test Y because, I mean, that's the whole point of the competition is that we're making the predictions, we submit them, get a score. But yeah, if you had your test Y, your labels on your test set, then you could see how well you did.
Well, and you could divide your training set.
Right. Cool. Which brings us to our next step, cross-validation. Cross-validation is one way to see how well you're doing. Cross-validation refers to taking your training data and splitting it among what we call folds. So in this case, I'm doing 5 folds. I'm going to split it in 5, and we're going to rotate on which piece we're going to treat as sort of a holdout or verification data set, and then we're going to train on the rest, right? So with 5 folds, we're going to take maybe the first 20%, separate it out. We're going to train on the second 80%, and then we're going to see how well we did on the first 20%. And then we're going to rotate what that, holdout data set is. With 5 folds, it's going to give us 5 scores. You can average them, take the standard deviation, check out the, look at the confidence interval, see kind of what your variance is overall, see how consistent your classifier is. So that's one way to sort of verify the validity or quality of your classifier.
Is that interval like the 50% range?
2 standard deviations is 95%.
Yeah, but it's a confidence interval, right? So that's
sure.
It's probably not a standard deviation.
Yeah, I just call it a standard. I call it a confidence interval, but it's basically, yeah. I guess 95% of your value should come in it. Yeah, I probably shouldn't call it a confidence interval. It's
After
not
Bayesian
exactly.
Oh, right. Sorry, I wasn't even looking at the math you had in there.
But it's the mean plus minus 2 standard
Right.
deviations, which is theoretically 95%. Cool.
Just say the probability is 95 out of 100.
Oh boy. There you go.
Do your frequency.
This is why we separate this. So by default, when you're doing cross-validation, you're sort of tuning to accuracy. But this is an example, same code where you can tune to whatever metric you want. So it's kind of interesting that we got something like an 82% accuracy, but only a 69% recall. So accuracy is decent, recall not so great on this case. But that's a good way to, maybe see another way of measuring the quality of your algorithm is, how does it do with this metric? How does it do with that metric? It kind of depends on your case. Scikit also gives you different ways of sort of stratifying and shuffling your data with cross-validation. For instance, if you got imbalanced data, you may want your cross-validation to sort of force a certain percentage of positives and negatives in each of your holdout sets. Kind of handy. Finally, we've got a grid search. Grid search refers to training across many parameters. So you give it a list of what parameters you want to try out, all the different values you want to try out, and you plug those parameters in, whatever classifier you want. And so we're actually combining grid search with cross-validation. So we're cross-validating against every possible combination of, in this case, these 5 parameters. The object we get out of that gives you, it actually gives you the data on every single, every cross-validation run. But if you don't want to look at all of them, you can simply grab the best classifier and the best score. And so we can see with this XGBoost, max depth of 4, learning rate of 0.1, blah, blah, blah. That's what gave us the best score overall across multiple folds. Does that make sense? Finally, you can chain multiple steps. So we had some pre-processing steps, and then typically you're going to have to do some data munging before you're going to do your classifier. So let's say we wanted to scale our data, use PCA to reduce our dimensionality before doing some sort of classification. Pipelines allow you to string all those together instead of doing separate calls for each step. It allows you to just put them all on a list. And you actually get the pipeline becomes basically your model. And so once again, fit on the known data, predict on the unknown data using the pipeline object this time. Any other questions? So that's pretty much classification. So scikit also gives you some canned data to play around with, some sort of regression-centric, like the Boston house prices. It gives you some classification data. The wine data set's kind of fun, classifying wines. It's got the iris data set, of course, the ever-present. In addition to that, though, one really cool thing, I think, is that you can sort of generate your own data, and you can sort of tell it, you can kind of control how, I guess, easy or hard the data is. You can control how separable the data is. When I say separable, I'm generally saying classifiable. You can tell it how many useful features, how many not so useful features, how many redundant features, and then how many clusters may occur in your data. So it kind of gives you a chance to experiment with different types of data. So in this case, we've got a fairly separable data set. If you call the yellow dots positives and everything else negative. This would be very easy to draw a line, which is often what your classifier is actually doing. You know, it's trying to find a boundary between your positives and the negatives. This one, not so separable. So if you want to sort of make it hard on yourself, you can generate something like this. There's also clustering. This is kind of cool. I don't know. I think this is kind of cool and really breaks down clustering really succinctly. This kind of shows you how each clustering algorithms perform based on your data arrangement. So I thought this was kind of insightful. K-means, which we've all heard about, it actually does not do so well on most data arrangements. But something like dbScan, for instance, handles those much better. But then, there may be cases where dbScan doesn't do so great either. So here's an example of a k-means coming from the cluster package. It actually gives you a fit and predict method in one method, which is kind of cool. And so applying k-means to the data above, giving it 2 clusters, here's what it comes up with. So it did okay, but it obviously picked a lot of items as negative, classified them as positive. It's not exactly classifying, but it's lumping them in the same cluster, I should say. You can tell it to look for as many as you want, as many clusters as you want. dbScan is, as you kind of saw before, it's a little more advanced. It's density based, and so k-means is distance based. dbScan tends to handle, I guess, just odd shaped data better than k-means. K-means tends to do better on more spherical data, circular, circular clusters, I guess. So dbScan is also kind of cool because it is actually willing to not classify or not take certain data points and not assign them to basically no cluster. So it's kind of handy for outlier detection. And as you can see, it did a pretty good job here of at least picking all the positives with just a couple items that shouldn't be in the group. So next we've got feature selection. One of the easiest ways to sort of trim your features down is to use a variance threshold. The idea is that features with low variance are not going to be very useful for your classifier. So you can give it a threshold, and in our case we had like 9 features. It's trimmed it down to 6. In our case, it's not going to make a big difference, but if you have hundreds of features, it can make a huge difference. Recursive feature elimination is really cool. It actually trains whatever classifier you want on all the features. It eliminates the least useful or the least important. Then it retrains on the next set, continuing that recursively, no surprise, until it gets down to the number of features you tell it to leave. So that's kind of cool.
Why would you ever want to do that?
Why would you ever want to do that? Well, just reducing your features is, could make your algorithm go a lot faster. If you've got, again, hundreds of features, which is common, that's the main reason, I guess. But
can it reduce overfitting as well? Reducing the number of features? Possibly.
Yeah, I think of the algorithm itself as sort of doing that by how you tune it, but
I was going to say it can help you identify bias. So if like your model was should not be predicting on gender,
right? You
just showed from that the sex is actually really important.
Right. And again,
sex is important.
It's it's contextual to. It's actually contextual to the classifier, so it's kind of interesting to see, what features are most important to what classifiers.
So is this something that it's already starting to tease out on output 30?
Yeah. So
I've already in order.
I've already basically created the object, and it's reduced to 5 features. and then I'm fitting on the data, and then once you fit, you get a model out of that, and the model will tell you which were most important and their rankings.
So this one's kind of interesting to me personally. I mean, when you're thinking about just the Titanic itself, when somebody embarks, if they've had, you know, an extra 5 days on the ship, maybe they know the exit's a little bit better, right? Or they don't. Is that something they're starting to?
S&C, is that right?
Yeah.
Yeah, we don't know. We don't know when they embark, but we do know where from.
Yes. So maybe if we looked at that, and then we could say, just look historically, we know, okay, they embarked from here.
Sure.
And that was the first step. First
Sure.
stop. Yeah.
Yeah, it doesn't give you that, but yeah, if you read up, you might find that that's the case. You might also find that just, you know, richer people come from this place or that, which seems to be the recurring theme here. If you're rich or a female, you're generally, or young, you're going to do better.
So I typically use principal components to kind of like reduce the dimensions down to multiple or retain a specific amount of variance. Is there the ability with RFE to get your retained variance to see like retain the number of dimensions necessary to keep like 95% of the variance, you know, like 90% or some threshold?
I kind of don't think so, but I'm really not sure. You probably just want to do PCA in that case.
There might be a callback function.
Yeah.
There's scikit-learn has callback functions for when it stops, and so like it could train and give you the columns. You could run that, the PCA again, check the variance, and tell it to keep going.
Actually, that's a good thought.
Yeah, you just do it recursively.
Yeah. Sort of manually. Yeah, that's good. That's about it for scikit. What else? Any other questions? I'll go through the actual submission notebook in a second. For now. Cool. So here's what I did.
How does scikit handle its like parallelization? Can like I haven't played around with too much of that. So there was one function that had to parallelize.
Yeah.
And I feel like that was probably
the grid search.
Yeah, the grid search did, and I feel like that was probably the like Python's built-in parallelization, I imagine. But do you know any more about that?
No, I really don't.
Yeah. I'm sure it has a lot of options.
Yeah.
Having looked at that, I vaguely recall it not being a multiprocessing module. Like there's something else going on there, but I can't remember what.
Huh.
Could it be G?
Could be what?
G.
Just spawn a bunch of.
Cool. So, here is my notebook, and these I'll put these out there. By the way, what's up? Oh,
not too many.
Yeah, just every classifier.
So that means there'll be charts.
What's that?
That means there'll be charts.
There will be charts. Make Ferris happy.
Yay! I like the pretty pictures.
So I actually start with some of the exploratory code you might want to do on this or any similar problem. First thing you might want to look at, of course, is correlations between your features and your label, or with each other. So you can, I think this comes from the stats. I forgot. Anyway, you can get a correlation matrix. You can also use something called Seaborn, which is pretty awesome for plots, and do a heat map on your correlations to kind of see, which features correlate to anything you want. It's kind of useful to do them on sort of the raw features, and then once you've done your encoding and whatnot, to sort of come back to it and see on your final data set what that looks like as well. Another good way to look at your data is the distributions, as Ferris pointed out earlier. You can look at the distributions of the features on their own. Again, I'm using Seaborn distribution plot, this plot. You can also do the distributions by your label, which is even more useful, using the facet grid, which is kind of handy. So you can actually separate them out by the positive and negative labels and see how the distributions differ. So for my case,
Seaborn also has one where it'll show the covariance, but it'll actually do the scatter plot of each of them and the distributions along the side axis.
Like throw everything at you.
Throw everything at you at the same time on one
I've
giant plot.
Seaborn's amazing.
It is amazing. So for my actual submission, I did lots of things, and I put some notes on my GitHub page, and you can kind of look through. I mentioned a few things that didn't work. Here I'll talk about mostly what did. If you remember, the data up top looks something like this. Like I said, some of these features are kind of obvious, some not so obvious. For instance, would the prefix mean something? Does the ticket code mean something? Does the cabin mean something? I tried all of them and found that prefix actually did make a difference. And when I say make a difference, I mean on the leaderboard itself. I found a lot of things that made a difference locally, and then, made no difference once I actually submitted. This was definitely a good exercise for me in overfitting and thinking about overfitting, dealing with overfitting.
That's how somebody got a 1 on the leaderboard.
Yeah, we can talk about that too. I mean, I've read some of the discussion boards, and people say, this is just people's opinions. I don't know if this is true, but most people suggest that anything over like an 85 or so is maybe cheating. Because you can look this up. You can also retry to get the right thing.
So you can theoretically retry until you explicitly specify every single one.
You can also just look people's names.
Yeah, just do a name table, and then
I don't know why you would do that.
Boom, data science. It's just one if statement.
My model is if this name. And
my model is memorization. So
what did you find?
Like I said, take that with a grain of salt, but that's what people on the discussion board seem to say. I will also say that I don't think I've seen a notebook out there where someone claims to reproduce more than 85 or so and says, here's my notebook that did.
Right.
Not saying they don't exist, I just haven't seen them.
And that's part of the discussion as well.
What did the ticket code, why did that even?
So it doesn't seem like it would be useful, but I'll actually show you a plot in a second. So what I do for ticket code, well, prefix is the prefix, no surprise. No magic there, just take. It's pretty standardized, the format, so I simply took the first word after the first comma. Ticket code is a UDF to take, basically, all tickets have this numeric code. Only some of them have this non-numeric code. So I cut that out and, lowercased everything, kind of standardized everything, and tried that out as basically a categorical feature. And it actually did make a little difference. Not a lot, but a little difference on the leaderboard. And so finally, here's what I actually kept. The fare, the siblings, the parents, the class, the sex, embarked, and then name, prefix really, and then ticket.
So H didn't make a difference in this case?
It sounds strange, but it did not for me. But again, it could be a combination of features I chose, and I'll talk about that a little more in a second. So that's not all the features though, that's just the first wave, I guess. So yeah, I take the prefix and the ticket code. I also took these two variables and just stuck them together in family size, the number of people you're traveling with. So now we're left with these. Do some imputation. Imputation wasn't quite as important because I think age is one of the big ones, and cabin was cabin code was one of the big ones, and I'm not using those. But I did go ahead and impute, I believe, the fare. I wrote this contextual imputer, which will do either median or most common. Median for numerics and most common for categoricals, and I do it by another column. So I believe if you're doing age, or fair, like fair I did by class, because the classes do kind of correspond to fair, or vice versa. Age, for instance, I think I tried it by prefix, which was much better than just doing median across the board, because, you know, a miss and a ms and a master. Master is actually a word for a young child, so, you know, so it kind of corresponded to age pretty well. Embarked, I just filled in with a hard-coded value because there were only 2 of them, and they sort of resembled other C's. Nothing, no magic there. More pretty pictures. So once I've got these features, I started taking a look at, I guess, what their survival rates were. And so I'm using, again, Seaborn. Always go back to Seaborn, using a factor plot to take a look at family size, for instance. And so from this, you can come up with some groupings of people more likely to survive, less likely, somewhere in between, which is kind of useful. Here's the prefix. Prefix is kind of funny. You know, women tend to do well, and men with fancy titles tend to do well. If you're just a mister, you're not. Yeah.
And again,
it's not looking good for
reference.
you.
And the survival.
If you're a sir or you know, a major, a little bit.
Captain.
If you're the captain, you get on the ship.
Yeah, I don't think the captain.
It's not really clear, but the survived is that y-axis right there, right?
Correct.
Is that a probability or percentage? Okay, just straight
and
percentage.
And then this little bar is the standard deviation.
Okay. So some of those deviations are probably one person.
Well, or 3. That one's probably
What's that?
2 people.
Yeah.
Or
ladies did good.
So like 1 person died, 1 person didn't.
In the training
median
data,
is in the middle, and your variance is entirely the same.
So
it's probably 2 people.
There's like 2 majors, 1 died, 1 died.
Yeah, there's like 2 kernels. There's probably 3 doctors or 4.
Exactly, and that's probably why finally, I one-hotted code, you know, the categoricals, just as I did previously. So based on those plots above, I did some binning. So I took, you know, most likely, least likely, kind of likely, and bin them together. I did that for that family size variable, for the prefix, and for the ticket code. Make sense? So taking family size, for instance, you know, if you were a solo, kind of your own group, it's kind of interesting how it's like the more people you travel with, it kind of helps up to a point, and then maybe it just becomes unmanageable or something to that effect.
You just ditch.
Yeah, exactly. If you're single, you've got no one looking out for you, something to that effect.
Wow.
So I kind of binned according to that.
Oh, can you dive into binning a little bit, what that means?
Well, binning is just my word for combining categories with similar survival rates. Okay, simple as that.
Do you ever bin like the fair amount into certain ranges? Did you try that?
I believe I tried that and age. Yeah, definitely age. Maybe fair. My theory on the age thing is that, yeah, some of the some of the prefixes kind of correspond to age, and so maybe it's kind of covering it to some extent. But yeah, I was surprised to see that age didn't seem to make much difference. I tried to make it make a difference, but didn't.
Do you know if that data set is the most complete, or did they purposely remove certain values in order to make it so you'd have to impute things?
Do not know. That's a good question. Someone should look at that.
Yes.
But not you.
No, I've had about all of this as well. So I kind of went down a rabbit hole with this because I think I got like a 79.9 within, you know, a few days or something, and I just couldn't break that. It was driving me crazy, and so it took me probably a couple more weeks. I mean, not every day all the time, but I kept coming back to it, and before I got that, you know, 81.8. And I'll kind of talk about what pushed me over on that. So there's our binning. Drop all the columns, the columns that we derive new features from, drop all of those. And so here's what we're left with, about 20 or so. I did try scaling fair. I think I tried the log because I saw that on somebody's. It didn't make a difference. So here's, I guess, two things kind of put me over that 80% mark. The first one was doing not XGBoost, doing quite a few different classifiers and combining them. So I won't go through each one, but I used XGBoost, and I'm doing grid searches, of course. SVM, extra trees, which is just another variation on random forest. There's a lot of variations on random forest. And then AdaBoost, and random forest itself. And finally, the voting classifier. Voting classifier, as the name implies, takes as many classifiers as you want and takes a voting approach. Simple as that. And so I tried probably 8 or so different ones. These all made a difference. So like logistic regression, KNN made no difference, or actually dropped the score. So cut them out. Voting classifiers, like any other, fit on your training data, predict on your test data. And finally, I generate the submission CSV. So voting classifier gave me, I think, something like 0.6, 0.7 increase. The thing that gave me the biggest increase, though, which kind of goes back to the overfitting, it kind of goes back to variance, I guess, in particular. And it's just kind of a random idea I had one day. I started printing out the 95% range, and I started, I would tune to the best accuracy. Accuracy is the ultimate metric we're doing here, by the way. I did try AUC just to see if it would give me a better, accuracy on the leaderboard. Didn't make a difference. But I started looking at the what we'll call a confidence interval, and in particular focusing on the lower bound. And I started thinking about, can I tune to, instead of tuning to just the best average accuracy, can I tune to the best accuracy but also the lowest standard deviation, right? So the idea was that it would be, more consistent, basically. And so perform consistently. I've had, averages as high as 85, but still couldn't break that 80% barrier when I actually submitted to Kaggle itself. And so this is what I did. I basically started tuning to this value, the lower bound on this, which is, a combination of your average and your standard deviations. And so I would tune to, the best parameter combination, and then I'd start tweaking them up and down a bit to see if I could get a boost on that lower bound. And that actually gave me like a whole point. And that's what got me up to that 81.8%. Any questions? I'll post the GitHub link. There's a few notebooks, but the two we went through today have the word meetup in them. So if you're interested, you can check those out. I've also got I've got my original, submission notebook, which doesn't really have much. And then I've got a homemade neural net approach, which if you're interested in such things, that's kind of worth looking at. So yeah, I'll post this a little later. Thanks for coming.
Any questions for Sean? Really in-depth data science.
Just can you talk about the, you said you originally got to 79 pretty quickly, and then how long did it take you from 79 to 81.8?
Probably like 3 more weeks. I know it was about 40, 45 submissions. I know that. I just kept trying different things. So yeah.
Did all the binning help? When did you try the binning? Was that like
That was
a day in? Is that like after a week of you
That
pulling
was
your
probably
hair
after a
out?
week, yeah.
Yeah. Okay.
Yeah, I really started to look back, like, is this really helping me or not? You know, started eliminating individual features, and then I tried binning and not binning, and the binning actually seemed to make a difference.
How much time did you spend on data preparation versus actual model tuning?
Probably 75% of the time is messing with the features themselves and seeing if I could just get the feature to do better, as opposed to the algorithm doing better. It's just like to produce better results, more consistent results. So that was the most frustrating thing. I was constantly getting better results locally, but I'd still be stuck at that 79.9. It was just driving me crazy. But,
So if you had like a limited time window to do this, say a day or something, what species would you focus on?
Probably use the feature importance to narrow down what the algorithm says is the most important, and just focus on that, and then put more time into the tuning of the algorithm. I don't know. Because most of these algorithms will give you that, by the way. Not all, but most can give you a sense of that.
How do you score on the neural net?
What's up? The neural net never broke 79.5 or something like that. But I could have taken that farther, but again, at some point I'm like, I got to start reading up on Kernels.
You don't have enough
move
data to
on
train a
with
neural
that.
net on that. There's no way.
Yeah. I didn't necessarily expect a neural net to do much better on this anyways, but it was just sort of a book I went through and thought I'd try it out. I highly recommend that book, by the way. It's called Make Your Own Neural Net in Python, if you're interested in such things. Cool.
Other questions? Sweet. Let's give another round of applause. Thank you so much, Tom. All right. That was a good talk. Somebody should write a figure out which features make it so that you're going to win the raffle. Or just figure out my random seed here, right? Sweet. So let's first make sure everybody has a number on their name tag. So look down at your name tag. Does it have a number? Is it an integer that is 0 or greater? If it's a negative number, you're not going to win this. If you don't, raise your hand. Sweet. Who is number 20? Who's 21? You are or you will be? Okay, so we'll start with 21. Where is the marker? That is the...
Out on the table, maybe?
Probably outside. I'll go. Who is number 22 then? Who did not get a name tag? Here's 22. Oh, you don't have a name tag? Okay. 22. 23. Or 24? 24. Oh, we'll just pass it backward to Matt. Oh. Matt's got it. You're 25.
25.
Okay, who's 26?
Okay.
We good.
Hey.
Here.
You're on 26 still?
Yes, you're 26.
Okay. Oh, that's
You guys don't want to write on yourself, too?
I'm not writing on the shirt.
So what number did we get?
27?
27.
Guess that makes me 28.
Yes. And Sean, did you get a number?
I did.
Stop writing, stop writing.
Anybody?
Who else is missing a number?
My brother too.
So we're up to 28.
Okay, nice. I'll do this round.
Oh, all right. Thank you. 28, going once, going twice. All right. Let's see if I can get this to work. I'm coding with the tiny screen. You see what I mean? This is how I get to see my screen. So let's see if I can even open a terminal. No? Oh, well, I'll do it the Mac way.
Keyboard shortcuts.
There's no keyboard shortcuts in Macs. Jeez. Dylan's just like, wait. Yes, yes. Okay. Let's give a nice clean terminal over here. Okay, that's so clean. Nope, that's the wrong size, isn't it? There we go. Oh, there we go. Cool. Live coding. You know what's going to happen? Yep.
Travis Python?
Yeah. So everybody knows how to install stuff in with pip, right? The new way.
Oh.
Yeah.
Fancy.
Oh. That makes sense.
This is the new way, so hopefully that'll work. There we go. And the bonus is because I use Python 3.7, I know that that's a Python 3.7 version, so we're good to go there, right? And, don't want that. Okay, let's see. Yes. So, how many Python uses do we have? 28, right? Is that where we got to? Anybody's 29? Okay. We actually have 30, but I'm 0, so we're going to subtract that, and then we can do random.randint. Nope, nope, nope. Boom. Pair programming.
Well, if you're going to subtract you might go from 1 to... Shouldn't you not go from 0?
No, because then it'll select 0 instead. Right? It's just convoluted. It's not elegant. That's why it's Python. I'm just kidding. Python's great. Okay, sweet. So we got 3 prizes going on today. We got a medium-sized V-cut Python Salt Lake City Python t-shirt. It's very lovely, very stylish. My dad hates the design, that's how you know it's cool. And then we have 2 Raspberry Pi 3s, which is kind of a tricky sentence. The Model B. This one has built-in Wi-Fi, built-in Bluetooth. So the only thing you need to add is an SD card and a USB, micro USB charger. And then you can actually start hacking away on it headless. Or you can add a monitor and a keyboard, and then you can like play Minecraft on it or do whatever you want. Who owns a Raspberry Pi? Just curious. Ooh, quite a few people. We should do a Raspberry Pi Python talk sometime, eh? Like, that would be a fun one. All right. I think it's time for the speaker to hit enter then. Syntax error. No, I'm just kidding. Number 13. Yeah. Your choice. You get 2 prizes. Your first is one of these. Your second is you get to pick the next prize winner. Sweet. Now just hit enter. Number 11. Yeah.
Choose the shirt.
The shirt is medium, just FYI.
Yeah, I'm
okay,
fine.
Sweet.
And enter.
16. Huzzah. Here you go, John.
Cheers. Thanks.
Cheers. Well, that's it for the meetup today. The next one will be August 1st. It's going to be about functional programming with Python, right?
Yeah.
Sweet.
Here's
Yeah.
the address for you, and I should have announced this earlier, but I will be giving a talk at the Utah Data Engineering Meetup a week from today on how to package up Python and push it into production.
And that'll be at Pluralsight.
Pluralsight down in South Jordan.
All right.
Yeah,
All
so
right.
join us at meetup.com, RSVP if you're coming, and we can plan through.
Thanks, Chris. Thank you.
What's that mean?
You all charged up?